Hey, welcome back. So the main project on this channel, Breezy, is all about making self-hosting super simple. I'm currently doing a lot of very exciting protocol research for that. So while that's underway, I thought I'd throw together this mini-series on self-hosting to better show what sorts of problems Breezy is actually trying to solve. So last week, I made this agenda app that I really want to use. It needs to be hosted so that I can access it remotely, but for hopefully obvious reasons, I don't really want anyone else to get in and read about my personal life. I also want to back up my data and have it automatically restart everything whenever something like a power outage happens. So, how would I go about doing that? Over the next 3 videos, I'll be setting all this up and self-hosting my app on a Raspberry Pi. If you happen to have a Pi laying around, feel free to dust it off and tag along. In this first video, we'll be setting up our Linux distro, which includes flashing the image onto our Pi, configuring our Wi-Fi, and setting up our user account with passwordless SSH access. In the second video, I'll deploy the web app I made as a service and set it up with daily backups. And then in the third and final video, I'll expose the Pi to the public network. That is, after I run a VPN server from my Pi, which is what locks out everyone who isn't me. So, let's get started. For my setup, I'm going to be going with Void Linux. It's not the most popular and is definitely not an easy OS that just works, but it's very simple. Not easy, simple. Nearly everything is manually configured, and there's not a lot of mystery bloat that can interfere once you're set up. So because of all that, when something does happen to go wrong, it's a lot easier to figure out and fix the issue. On Void's website, we'll head over to the download page, then the ARM Platforms tab since we're deploying on a Pi. To know exactly which version to download, I'm going to check out this in the documentation link. And for Raspberry Pi 5, I can see that I should download the ARC64 version. Back to the downloads page, that's this RPI ARC64 category. And I want the platform image. Once that download's done, I'll need to grab the Raspberry Pi Imager software that's used to flash the image onto my micro SD. I'll go ahead and download that, run the DMG it gives me, drag it over to Applications to install it, and then launch it. At this point, my micro SD card is plugged into my laptop, so it's also ready to be imaged. I'm using a Raspberry Pi 5, and I want to install a custom OS on it. Let's choose the void image.xz file we downloaded earlier, choose our micro SD card, and give it a whirl. Now off screen here, I'm putting the micro SD card back into my Pi and booting it up. Once it's running, I'll be good to log in. Void Linux's instructions for logging into this particular image is to use root with the password void linux. I have my Pi hardwired into my router, and I already know its IP address from past installs, so I'm just going to SSH into it. You probably aren't in that situation, so you'll need to log in with a keyboard and monitor directly plugged into your Pi. Once you are logged in, you can run IP space ADDR to list out your network adapters. ETH0 is your hardwired Ethernet connection. If you're hardwired in, this should show an IP next to iNet, which you can use to SSH. You'll see mine matches the IP I used in the SSH command above, which is 10.0.0.120. If you're not hardwired into your router, which is far more likely, no worries. We'll set up your Wi-Fi in a second, but first, let's make your shell session a little bit easier to use. We can see what shell we're using by running echo space $, and then shell in all capital letters. We can see it's just the standard sh shell, which is missing all of the wonderful features like tab complete and pressing up to scroll through your last few commands. To switch, we run the chsh command change shell, providing it with the shell that we want to use, in this case /bin/bash. and then we exit out and reconnect to get a fresh bash shell. We can run the echo shell command again if we want to confirm, though our terminal prompt does explicitly say bash in it now. Moving on to Wi-Fi. So before we configure our network, first we need to enable our wireless adapter and the WPA supplicant service. The IP link command lists out all the adapters that we have. It's very similar to the IP ADDR command we ran earlier, but with far less information, so it's a bit easier to read. The LO adapter is your loopback interface. That's what makes things like localhost and 127.0.0.1 work. ETH0, as mentioned earlier, is your 0th Ethernet connection. Remember, programmers start counting at 0, not 1. Then WLAN 0, if you haven't guessed already, is your 0th wireless LAN adapter. That's the one we need to set up. We'll start by enabling it with the command IP link set WLAN 0 up. Now we need to run the WPA supplicant service. WPA stands for Wi-Fi Protected Access. So enabling this is basically turning on the service, which allows us to connect to a router. Void Linux doesn't actually use systemd to manage its services, which is probably my favorite thing about Void if I'm being totally honest. Instead, it uses runit. Runit? runit? To enable a service in runit, you drop a link to the service configuration inside /var/service. If we list out all the services that are configured to run, you'll see we have about 10, but none of them are the WPA supplicant service. Runit's service configuration files are stored inside /etc/sv. The SV stands for service. Listing out the directories in here, we see we do have the WPA supplicant, which means the service already exists, we just need to enable it. To enable it, we create a symbolic link from that WPA supplicant directory into our var service directory. That's it. It's now enabled. We can check the status with sv status WPA supplicant, and it shows it's running and how long it's been running for. If we run that command again, we can see the timer increased to 5 seconds, which is a pretty good indication that it's running correctly. It hasn't immediately crashed and tried to restart itself yet. Okay, finally, let's get our Wi-Fi network set up. To do that, we'll enter the WPA CLI using our WLAN 0 interface from earlier. Once we're in, if we run the scan command, it'll kick off a scan of all the networks it can see. To view the results, you'll need to run scan_results. It might take a few seconds, though, for the original scan to finish first. I'll be connecting to the GLaDOS 5 GHz network. You'll want to note your network's exact SSID if you don't already know it. To start adding this as a known network, I run add_network, which returns a number, probably 0. This is the network's ID and is what we'll use to refer to the network in future commands. You can list out all of your networks with list_network, which at this point should just be the one that we created. If at any point something gets messed up with your configuration, you can run remove_network followed by the network ID to remove it from the list. But we want to add a network, so I'll rerun that add network command. Note that we get back the ID of 0, set the SSID of network 0 to be GLaDOS 5 GHz, and the passkey to be my super secret password. We'll need to enable the network, then select it, and if we want, we can check the status. If everything looks good, I'll run save_config so that the configuration is persisted across reboots, and then quit to get back to my bash session. Now, if I run IP ADDR, I can see my WLAN 0 interface shows an IP address, 10.0.0.122. To confirm it's working, I can SSH into the Pi from my MacBook, and yep, sure enough, looks good. Now that our internet is set up, we can update our OS packages and install our text editor of choice. Void Linux uses XBPS as its package manager. To get updates, I'll run xbps-install space -S_u, and it's telling me that XBPS itself needs an update, so I'll go ahead and do what it says and run XBPS install -u XBPS. And now we should be ready to go. By default, Void only gives us access to VI. Not Vim, not Nano, just VI. We can search for packages using XBPS query -R lowercase s, and then the package name, like Nano or Vim. Personally, I prefer Vim, so I'm going to go ahead and install that using XBPS install -S lowercase u Vim, but you can install whatever you're comfortable working with. Up until now, we've been using the root user for pretty much everything. It's not really a best practice, though, to use the root user, so we're going to create ourselves a new user, and this can actually make it a bit easier to log into the system as well. The main user on my MacBook is named Ben, so I'll create a user with the same name using this command here. The -m flag creates a home directory for the user, and -s sets the user's default shell to bin bash. To set a password for my new user, I'm going to run the password command followed by my username. Then to give my user admin level permissions, I'm going to add them to the wheel group by using usermod, which is short for modify, with the -a to add and -G to the group called wheel. For sudo to actually work, I need to edit the sudoers file, which I'll do using the vi sudo command. This puts you in the VI editor, so if you're not familiar with VI or Vim, make sure to copy my keystrokes exact or you might end up messing up this file. But note that if you do accidentally change a bunch of stuff, press the escape key, then :Q, exclamation point, followed by the enter key. That should quit out without saving anything. The first key is a /, followed by WHEEL, and the enter key. This searches the file for the word wheel. Then I press J to go down a line, the number 0 to go to the start of the line, and lastly XX to delete the comment at the beginning of this line. Then to save and quit, I type :WQ, and then press the enter key. To make sure all of this worked correctly, I'll exit the connection, then try to log in as my new Ben user. If you're SSHing into your Pi like I am, and if the username you created on your Pi matches the user on the machine you're SSHing from, then you can actually omit your username from the SSH command. I'll do that here since Ben matches Ben. The final step to getting our OS and user accounts bootstrapped is to set up an SSH key. I'll need to create an SSH key on my laptop first, but if you already have one in your SSH directory for some other reason, feel free to just reuse that key. SSH keygen is used to generate a key. I'm going with the ED25519 key type. It's a little more secure than RSA, but basically any common key type should work fine. The default values for these prompts are also fine. There's no need to set a password on the key unless you really want one for some reason. I need to copy the public key to my clipboard, so I'll print that out on the screen. Make sure you use the file ending in .pub, or you might end up inadvertently sharing your private key. Back to the Void Linux terminal, I'm going to create a .ssh directory in my user's home directory, then create and edit the authorized keys file within that directory. I'm going to paste my public key that I just copied, then save and quit. Now from my MacBook's terminal, I'm going to try to SSH again, making sure that it does not prompt me for a password anymore. Since we're about to turn off password authentication for SSH, it's important to verify that you don't need to give a password or you risk locking yourself out of your Pi. If you do find yourself locked out later on, then you'll just need to log in with a keyboard and monitor plugged directly into your Pi and try to fix whatever went wrong. Disabling password authentication for SSH is a good thing because it makes it much harder for someone to crack into your system. To disable it, you'll edit the etc ssh sshd config file using your editor of choice. Note that you'll need sudo on this command. Search for the line that reads password authentication yes. Uncomment that line and change the yes to a no. Save and quit, restart the sshd service, and you're done. To verify it's all good, I'll check from another terminal that I can no longer log in as root, since we never set up any SSH keys for the root user, and that I'm still able to log in as Ben successfully. Now, was that not the most fun setup process you've ever endured? Okay, so if you've made it this far, you probably got some enjoyment out of it, but most people don't, and that's kind of the point of why I'm making Breezy. In the next video, I'm going to show you how to deploy a personal web app to the Pi as a Runit service. And in the following video, I'm going to secure the Pi so that myself, and only myself, can access it from any public network. You can expect both of these videos to be released within a couple of days of each other. And then after that, we'll be back to the regularly scheduled Breezy devlogs. Hope you enjoyed, and I'll catch you in the next one.